Here we go, everybody. Video 2 of 3, our second video. I think I said it was going to be arc length. Our third video is actually going to be arc length. Our second video here is going to be about inscribed angles. Inscribed angles really does go pretty well with your textbook, section 10.4. So that is a reference if you want to use it, section 10.4. So again, hopefully you've got something ready to write on, ready to write with. The calculator stuff I mentioned before in the first video really won't need a lot of it still until probably the third video. Definitely will. But it's okay to have it handy. Could still use it for this video. So here we go. First thing we're going to do is we're going to copy down circles. So we're going to have circle 1, circle 2, circle 3. I'll be demoing circle 1 example and circle 2, and you'll be trying circle 3 on your own. Then I'll erase all that, and we'll have 2 more. We're going to put quadrilaterals, 4-sided figures, inside of a circle. I'll do the first example, so example 4 I'll do, and then you'll do example 5 on your own. And that's pretty much going to cap up video 2. Video 3 will be arc length. I am right on that this time. So third video will be finding distance around a circle called arc length. So far we found measures of arcs, found central angles, learned about types of arcs, and now we're going to do inscribed angles. Okay, so what is an inscribed angle? An inscribed angle is an angle whose vertex is on the circle. The vertex has to be on the circle. That's hugely important. And it's also then the rays, the sides of the angle, has endpoints that are also on the circle. Okay, so we need you to copy a circle, make a circle. Just like last video, A and B are going to be these like ends of the angle that are endpoints on the circle. And then the vertex is going to be C. And there is a center of our circle D. D is our center. Now, hopefully you see these small little symbols I put here. Those are Greek letters. We have talked a little bit about them before. You learned about them in a couple of the other previous videos the last couple of weeks. A lot of times the geometry and trig, and even with circles, we like to use Greek letters kind of in place of angles. So our first one here is theta. It's like a circle with like a little line through it. So that's theta. It represents a certain angle that you can eventually write down what the degrees of that angle is. But we're just going to say then theta and then alpha. Okay, so alpha is going to represent this angle C, angle ACB, and ADB or angle D is going to be beta. Okay, or excuse me, beta. Theta. Okay, well, here's the relationship. We know that the central angle, the relationship to the measure of the central angle is going to be the exact same thing as the measurement of the arc that it intercepts. Now, with inscribed angles, I know that whatever the central angle is, it is going to be twice as big as the inscribed angle that it intercepts with. For example, if theta is 60 degrees, then that means that the measure of arc AB is 60 degrees. Measure of arc AB is 60 degrees. Okay. Well, then that tells me now that angle ACB, otherwise known as the measure of angle C, that is going to be half as big as that. Half of 60, it's going to be 30. So this angle right here, theta is going to be 30 degrees. Okay. So the inscribed angle is always going to be half of the central angle, or you can say that it's half of the arc that it intercepts. Now you notice that this ray CA, this ray CB, they are intercepting that arc. If the inscribed angle is not intercepting that arc that's coming from the center, it's not going to work. Okay? So it just think of it in terms of real simple, even if you don't have a central angle, that the arc is twice as big as what the inscribed angle is that intercepts it. Okay, so following that, we're going to draw another circle. We've got a diameter. So D is a point on the circle. E and O and G are all collinear. They're all on the same line. They're part of the diameter. So E and G are opposite sides. O is our center of our circle. And we do have a fifth point here that is F. So we want you to go ahead and make that circle. And if you didn't understand anything with the first example, maybe hit pause, rewind, just watch it again. Okay. So here we go. I want to know a couple things here about this one. So I want to know what is the measure of arc. I want to know what is the measure of. Actually, I want to know what's the measure of arc DG. So what is the measure of arc DG? I also want to know what is the measure of angle G. So what is the measure of angle G? We could say it's also EGF. Okay. So let's start with that. If I want to know what is the measure of arc DG, again, the arc is twice as big as the inscribed angle that it intercepts with. So if the inscribed angle is 40 degrees, then the arc is 80 degrees. Okay? And now I want to know what is the measure of angle G. Well, angle G is an inscribed angle. Its vertex is on the circle. And we have an arc that it intercepts that is 58 degrees. If the arc is twice as big as the angle, then that means the angle is going to be half of 58, which is going to be 29. Okay, let's copy a third one down. You'll be doing this one on your own. Oh no. Oh yes, you can do it. Again, we have T, X, R. That is going to be, they're collinear. X is the center. TR represents a diameter. We've also got a point Q up here. And we've got a point S. There's two things that were given to us. Angle R was 50, and arc RS is 48. So here's what I want you to find. Once I write this down, go ahead and hit pause and answer the two questions. So what do I want to know? I want to know what is the measure of angle T, and I also want to know what is the measure of arc QR. Go ahead and find those two things right now. Take a look at what we've talked about. Look at the previous example. Hit pause, answer them, and then we'll come back and figure out if you were correct. See how you did. Bet you did really well. 100%. Let's go check it out. First one, angle T. Angle T is an inscribed angle. It's going to be half as big in degrees as the arc that it intercepts, which is 48 degrees. Half of that is going to be 24 degrees. Everybody's hand up. They got it right. Look at all those hands in the air. Yeah, hands up. Next one, I've got, I want to know what is the measure of arc QR. Arc QR. A little harder on this one. A couple things here. I do know that angle R is 50. So then I know this arc QT, which I didn't really ask for, but you're going to need it. Arc QT is going to be 100 degrees. Well, remember again, we want QR. QR is going to be that missing piece right here. Well, I know that if I have arc TQR, that's going to be 180 degrees because TR is a diameter. So then if TQR is 180, I take 180 minus 100, now I'm down to 80 degrees. So final answer, 80 degrees, measure of arc, QR. A little tougher. Maybe you can see a few people having a harder time with that one. Maybe rewatch, try it again. That's definitely something you'll have to be able to do. Find one angle that doesn't seem like you really need in order to get another angle that you do need. Okay? Last part now. We're going to talk about having inscribed polygons. So inscribed polygon is a four-sided, in this case we're going to do inscribed quadrilateral. So I put polygons. We're going to focus today on quadrilaterals. So inscribed quads. So four-sided figure inside the circle. All of the vertices have to be on the circle though, otherwise it's not considered inscribed. And when this happens, we have what's called a circumscribed circle. So it's a polygon that's inscribed inside of it, so thus we call the circle circumscribed. So first thing is to copy this, draw the circle, and then draw the four-sided figure, draw the quadrilateral. So we've got D, E, F, G. We're going to label angle D as just X. That's a missing angle I'm going to ask you to find. We're going to talk about finding together. Next one is angle G, which we're going to label as Y, the missing angle. I want to find that. We've got angle E is 120 degrees, and angle F is 80 degrees. Okay, Any question on that? Okay, so first thing we're going to look at it and say, well, we know that 360 degrees makes up the inside of any four-sided figure, any quadrilateral. Well, right now, we know that 120 and 80 is going to get us 200. So I've got 160 degrees left. Well, we're not going to divide by 2. You can tell that those two are not the same. Here's the secret to these problems. When you're doing inscribed quadrilaterals inside of a circle, opposite angles will always be supplementary. Okay, that's diagonal. So these two, D and F, are going to be supplementary. And these two, G and E, are going to be supplementary. So as long as you know one, if you take 180 minus that, you're going to find the other. So if I take 180 minus 80, angle D is going to be, or X is going to be 100 degrees. Okay. And then finally, if this one's 120, 180 minus 120 is going to be 60. So then Y is 60 degrees, or you would say angle G is 60 degrees. Okay. Any questions on those? Okay. You're going to do the last one here, so we'll hit pause one more time on the video, and you're going to finish this off. We'll finish this strong the right way. So draw another circle, draw another four-sided figure. Vertices are A, B, C, and D. Does it have to look exactly like this? No, just make it look somewhat close. Angle A is going to be C in terms of C degrees. That's a variable. We need to figure out what that is. Angle B is 111 degrees. And angle C is 65 degrees. Angle D is 3 times A. So we're going to obviously have to figure out what that is. So go ahead now. Here's what I'm looking for. I want to know what is just the variables. What is A equal? And what is C equal? So we'll hit pause one more time. Try these two. We'll be back in just a moment. Back for the finale. Let's get these last two. Make sure we're good before we move on to video 3. So here we go. Answer, what is A? What is A? Well, A is going to be 3 times A plus 111. That's going to be 180 degrees. So if we take 180 minus 111, I'm going to have 69. So I know right now that 3A equals 69. What is A? A is 23. 23 degrees. And what is C? Not angle C, but the variable C. If I take 180 minus 65, I'm going to get 115 degrees. So I know then that C is 115. Any questions on those two? Hopefully that makes sense. Obviously go back and rewind, go back, watch the video again. You get a chance to practice it with some of the activities you have. Overall though, I thought you guys did a great job of listening and participating. Amazing. I could just feel the energy coming my way. Just that so much energy coming my way is going to help me for the 3rd video. So there'll be one more video. Breathe. It's going to be over arc length, and it's going to be my best of the 3. So go Titans. Check out video 3.